In this video, we're going to find the zeros of polynomial functions. Zeros is another word for x-intercepts. Usually the way we find these x-intercepts is by factoring the polynomial, set the factors equal to 0, and solve for x. But sometimes we just don't have a traditional way to factor those polynomials. The rational zero or root theorem, which is what we're going to be looking at today, gives us another method to find these x-intercepts or zeros of a polynomial. The theorem states that a list of possible rational root zeros of a polynomial can be found by taking the factors of the constant term, which we're going to call p, and dividing them by the factors of the leading coefficient. Now these are rational zeros. Remember, a rational number is the ratio of two integers. In other words, a fraction. So even a whole number 5 can be expressed as the ratio of two integers. 5 over 1 is 5. What's an irrational number? It's like the square root of 3. It is a real number, but cannot be expressed as the ratio of two integers. So this theorem gives us a list of possible rational zeros. So let's just dive in. The first two examples say make a list of possible rational zeros. You really want to make sure you read the directions. A list. It doesn't say to do anything else. So going back to this theorem, I need to know what the constant term is. So my constant term is 15. So what all multiplies to get 15? Well, I know 1 times 15 and 3 times 5. But also, I could have some negatives, right? A negative times a negative could also be positive 15. So I want to list those as plus and minus. Then I need my leading coefficient. The leading coefficient would be 1, and the factors of 1 are plus or minus 1. Have I made my list? No, I have not. Go back and let's read. It says, found by taking the factors of the constant term and dividing them by the factors of the leading coefficient. So I need to divide. So I'm going to take the factors of the constant term and divide them by 1. Well, when you divide by 1, you get the same thing. So my list is going to be plus or minus 1. I'm just going to go ahead and put it in numerical order. Plus or minus 3, 5, and 15. And all of those divided by plus or minus 1, I would get the same thing. And I will stop. It just says make the list. And that's what I'm going to do. So let's look at number 2. So my constant term is negative 5. So what multiplies to get 5? 1 and 5. And again, it could be a combination of positives and negatives. My leading term is 10. What all multiplies to get 10? Well, 1 times 10 and 2 times 5. And again, I need positives and negatives. So now I need to divide. I need to divide P divided by Q. So here's my list. So I'm going to take and I'm just going to put a plus or minus out in front. Kind of be a lazy way. So I need to divide 1 over 1, 1 over 10, 1 over 2, and 1 over 5. Then I need to divide 5 by all of those. So 5 over 1, 5 over 10, 5 over 2, and 5 over 5. And of course, they can be plus or minus. I'm going to go ahead and reduce some of those fractions. So that's 1, 1/10, 1/2, 1/5. That's 5. Now 5 over 10 is the same as 1/2, so I'm not going to list it again. And then I have 5 over 2, and 5 over 5 is the same as 1. So that's my final list. Now let's say this question was on the test and you didn't reduce and you left the same as 5 over 5 and 1 over 1. I'm not going to count off for that because it still will show me that you know what I'm talking about when I say make the list of possible zeros. So that's all there is to it.